There's a few more joining as we speak, but we'll maybe just kick this on. So many thanks for joining us today for our Smart Emergency Lighting webinar in conjunction with Hochiki. We are joined today by Richard Warren from Hochiki, who will shortly take us through the presentation. After the presentation, we're going to have a quick Q&A session. You each should have the facility there to type any questions you have into the Q&A section of the screen, and we'll run through each of those following the presentation. We'll just allow Richard to run through the presentation first and then do the Q&A at the end. We've also got a quick feedback poll, which we're going to pop up onto your screens at the end while we wrap things up. So if you could just take a wee minute to complete that, we'd appreciate it. Just a couple of yes and no questions. Don't worry, we're not looking for chapter and verse on comments fields. So without any further ado, I'd like to hand over to Richard to introduce himself and take us through his fantastic presentation. Hello, Richard.
Hello, Pete. How are you doing? You all right?
Superb, thank you.
Wonderful. Well, hello, everybody, and thanks for joining us today. Today I'm going to be running through the FIREscape Emergency Lighting webinar and just showing you a little bit about the FIREscape system. Okay, so without further ado, would like to welcome you, obviously, but we're going to run through it about this and tell you about a bit of the importance about emergency lighting and the solution that Hochiki has that can solve some of the issues around testing, compliance, and energy consumption. So the importance of emergency lighting. Well, obviously, it's extremely important, especially in this day and age, with the complexity of some of the buildings that we now inhabit and work in. So emergency lighting saves lives. Now, although you may see it as just a legal tick box, in an emergency, having adequate emergency lighting can be the difference between life and death. In many older buildings, they still use halogen and tube fittings and central battery systems, which are not only inefficient, but they're also expensive to run. But all too often, the light output does not always meet the requirements of BSEN 5266. Compliant emergency lighting systems ensure that the building occupants can identify first aid points, locate fire safety equipment, avoid hazards, and escape through the closest emergency exit. The question is, if you can't see it, how do you expect others to? So we're introducing FIREscape. It's a conspicuous, compliant, cost-effective solution. It's a brand new concept, and that is the way that this system works. It's how it fits together and what it can offer for you and your building. So moving away from bulkheads and central battery system, we offer a completely unique, cost-effective and fully compliant emergency lighting system. FIREscape is based around an addressable emergency lighting control panel with a battery backup and features addressable self-contained LED luminaires and exit signage connected via a screened extra low voltage 40 volts cabling. Furthermore, FIREscape is a fully self-monitored and self-testing system with a central point of control, making installation and maintenance quick and easy. So what makes FIREscape unique? So it's cost effective. So FIREscape has been designed to reduce the total cost of ownership. Features such as extra low voltage cabling, central monitoring, simple installation, and hassle-free maintenance reduces your labor cost. Plus, the LED luminaires also save money on lamp replacement costs, battery replacement, and energy efficiency. Over the total life of the system, a building owner can expect to save tens of thousands of pounds. It's environmentally friendly. Now, FIREscape's standard LED luminaires consume less than half a watt when charging. And then once these units are fully charged, they actually turn themselves off. And at that point, they only consume 0.1 of a watt. Even the high-powered version, the high-powered luminaire, that consumes less than 0.2 of a watt when fully charged. A similar 8-watt fluorescent light will typically consume 12 watts. Now, this directly corresponds with lower energy consumption and lower CO2 emissions, giving the building owner a greener and more cost-effective solution. It's fully compliant. So all the luminaires are certified to BSEN 60598 Part 2 22, BSEN 62034 Type PERC, and are approved under BS Kite Mark 653255. All the exit signs are BSEN ISO 7010 compliant, and the full system meets the requirements of BSEN 5266. All the photometric data and energy efficiency calculations have been verified by third parties and can be found on our FIREscape catalogue. Third-party approvals confirm that FIREscape is a high-quality system that will not fail in an emergency, giving building owners total peace of mind. Be aware, not all products on the market are fully approved or compliant with the standards. So the system is self-testing. FIREscape is a fully monitored, self-testing system with addressable devices. The EL2 control panel continuously monitors the status of the luminaires and exit signs. If there is an uncharged battery or a device fault, the system will quickly locate and identify the problem, therefore making maintenance quick and easy. Plus, completed test reports are stored in the memory of the panel and can be printed for end user records as required by EN 50172. We use low voltage cabling, so the panel is connected to the mains power to monitor for failure. However, the cable that runs between devices is extra low voltage. That means the majority of the installation and maintenance does not have to be carried out by a qualified electrical engineer, drastically reducing labour costs. It's feature-rich. So FIREscape is feature-rich with adjustable lighting levels, an intuitive graphics package, bi-coloured status LEDs, day and night modes, and the ability to program units as maintained or non-maintained. The wide variety of system features and product accessories not only helps to make the installation simpler, but it also enables the installer to provide a flexible and cost-effective solution tailored to the requirements of the building and the building owner. Central to the range is an addressable emergency lighting control panel, 4 LED emergency light luminaires, and a BSEN ISO 7010 compliant exit signs. The luminaire range also includes 2 high-powered variants for high-risk task areas. Exit signs are available with up, down, left or right legends and are available in 20-metre or 40-metre viewing distances. The range also includes a variety of accessories, and that includes recess adapters, step lights, weatherproof enclosures, brackets, batteries, input-output units, and a common mounting base, and much more. It's easy to install and maintain. So all the FIREscape devices, they use the YBN R3 common mounting base that we commonly use for our fire products and our ESP protocol, making it easy for the existing Hochiki installers to understand and install the FIREscape system. The self-testing features also help to make it an ongoing maintenance quick and easy. Each panel can have 2 lighting lines with 127 devices per line, and up to 49 FIREscape panels can be networked together via using the use of serial connectors. Alternatively, an infinite number of FIREscape panels can be networked together using LAN cards, and that's dependent obviously upon your IP addresses available. Whether it's a small or a large building structure, FIREscape can be scaled to suit your building requirements. When used in conjunction with third-party software, FIREscape can be connected to a building management system. Having remote central control helps building management to increase staff productivity, manage maintenance more efficiently, and effectively monitor energy consumption. Central control is particularly beneficial when working on a large or complex site. So we're going to have a quick look at the system design. Initially, I'm going to show you typically what an addressable emergency lighting system is currently wired like. So this is what you might see on another site, you know, a typical addressable emergency lighting system. So to the right, we have a lighting distribution board, and we're feeding mains into all the K, which is the test key switches, which then in turn feeds your emergency lights. These typically would be your local lighting circuits. With traditional systems, you're going to have a second cable to talk to the emergency lights. So that's where we have the addressable lighting control panel, and we have a second cable going into every single fitting. On FIREscape system, now this is a basic design of it, and we're only showing one of the lighting circuits here just to simplify this. We basically have the control panel, which is F2, and then we have a data line that comes straight out of that. Now, you can see on that data line, we've got the circles, which are downlighter luminaires. We have the green oblongs, which are the exit signs. And then we also have the little gray diamonds. Those little gray diamonds are connected to the blue diamonds, which is your lighting distribution board. This is so we can effectively monitor a local lighting circuit. So in the event of a power failure in, say, the ground floor, we can that will tell the input-output unit which circuit has failed, and then we can bring on the corresponding lights in that area. By doing this, it allows us to bespoke a system and alter it very easily if you have building alterations or want to run some weird and wonderful cause and effect where you actually bring on lights in separate areas around it. This diagram is an expansion of that. It's realistically showing the same again, but we're now bringing in a second panel with multiple keypads on the second panel, and then we're networking those together, and this would be typically used over a larger site. Having said that, this diagram actually shows it on a very large scale. So we've got 3 panels here, each one showing 2 lighting circuits. They are all connected together via the Ethernet or the RS485. We've got a graphics package on site, and then we're also broadcasting via the internet to a remote graphics package. So again, this could be monitored from the other side of the city or across the world if you really wanted to. So just to quickly run through some of the technical details of it. It's a fully monitored with automated testing system. It's using LED technology. We can have maintained or non-maintained operation. We have digital transmission signals immune to interference, and it's utilizing our renowned ESP protocol that we use in our fire detectors. There's no main 230 volt wiring into any of the fittings. There's no requirement to wire this in fire rated cable. It's not a central battery system, it's a centrally controlled system. Each fitting actually has its own battery in the device. We use a common mounting base for easy installation. What this actually does is it means you have a connection plate on the ceiling. All the actual controls are in the luminaire head, which can be removed with smoke poles. So we can actually get around the need for using step ladders to get up to some of these fittings for ongoing maintenance. We use simplified wiring. So on the diagram I showed you the cable going out, that is a screened 2-core cable, typically a screen Belden. So there's no mains in that. So we're transmitting all our data and all our power down the one cable. We can put an IP interface on there, a full graphics option, a GSM pager interface as well. Each individual control panel can have up to 8 keypads on that panel. It actually says 15 panel network on here, but actually it's a 48 panel network. Now each of those panels can have up to 2 lines per panel, and each line can take up to 127 points per line. So the scalability of the system, where we can, the amount of devices that we can put on it is quite large. So we'll just dip into the product range now and just run through these. So typically you're going to have your exit signs. So we use a cup and socket kind of effect. So at the top of the actual image, you'll see the circular cup. Now in that cup is where we house the battery. We use a 7.4 volt lithium polymer battery. It's a very intelligent battery and it monitors for a lot of different potential issues you can get with any battery. It literally just twists into the base. And then we've got obviously the frame hanging part of it, and you choose what legend you want on there. So we have the 20-meter viewing distance one and the 40-meter viewing distance fittings. All of the arrows we can get on it, up, down, left, right, we can get those in the BSEN ISO 7010 approved. There are other standard ones that we do and can get hold of if your building requires it. Now, we're very modular. We like to use the same fittings and don't see the point in, you know, having to design something completely different when we have got a perfectly good fitting. So when we get to the recess fittings, we are still using the same frame and hanger situation, but we introduce the actual recessing adapter. Now, the recess adapter, as you can see from the image, just allows it so that all the frame and the frame hanger and the cup go up into the ceiling, and essentially what you will have is the blade of the actual exit sign hanging down below to keep it very neat and slick. This is our corridor downlighter. Now, again, it's the same. It will twist into the base. You can actually see the base on this one. There's a very thin line section at the top, and that is the actual base. So the battery is still in the head. With the luminaire, you may see that the lens on that is slightly oval shaped, and that is so that we give a corridor shaped lens. We're trying to be efficient with the actual light as well as the energy on these systems. So we're actually trying to throw the light where it's actually needed, which is on that center line of your corridor. Now, mounted at a certain height, you will get spacings of up to nearly 15 meters between fittings, and you're still going to achieve the one lux that you require on that center line. The ELDL3, the open area downlight, is very much the same fitting. However, the lens is designed to evenly distribute the light over a larger area. As required for open areas, we require half a lux on the floor to meet the standards. Typically on this one, again, dependent on the height you mount it, we're going to get spacings of up to 8.7 meters between fittings. Both the ELDL2 corridor fitting and the ELDL3 open area fitting can be mounted in their respective recess adapter, giving you a clean look to the ceiling if required. The recess adapter can also be used for the high-powered versions that we're about to see in a moment. The nice thing about this fitting is that, again, we're being modular, we're using the same fittings, but when you take this one out via the two slots on the side, it drops the whole central section out. So if you had a nice false ceiling, we've all seen false ceilings getting damaged by people taking things in and out of them, like fittings or anything that's been recessed. So it leaves the outer shroud in the ceiling. So we're just taking the central section out. So we're, again, hopefully protecting the ceiling and making that look nicer for longer. The NFW89 high-powered downlighter, again, it's similar style of fitting and to the ELDL2 and the DL3, but it's been designed, it's slightly deeper as we need to house a larger battery in this one. Again, it's available in both the corridor and the open area lenses. Now, with this fitting, it can be mounted at heights of anywhere up to 12 meters. I've seen this mounted and still provide the correct amount of light when obviously the system is designed correctly. At 8 meters high, we can get spacings of up to 22 meters between the corridor fittings and still achieve one lux. Alternatively, you could use this at a lower level to provide a higher lux level, for example, 15 lux on a kitchen work surface. The weatherproof housing, we're being modular. The fitting goes straight into these weatherproof housings, the DL2 and the DL3, and they are an IP67 weatherproof enclosure. The wall mount version, as you see there, is specifically designed so the light is actually thrown where the light is actually required, which is on the floor. The nice thing about these is they have a certain amount of vandal resistance as well, and we've all seen emergency lights damaged on the outside of buildings and looking in a fairly sorry state at times. The ELSL is a step luminaire, so typically going up your stairs you could have these at certain intervals to provide additional lighting on the steps, and it's typically for illumination of steps and changes of floor level if required. The keypad is used to display the status of the system. It can be used to interrogate the system for reports, event logs, luminaire status, start manual lighting tests, and much more. As mentioned in an earlier slide, you can fit up to 8 of these per control panel. Also on the diagram I showed earlier, I pointed out the little grey diamond, which I said was an input unit. This is the actual input unit that we use. So each of these units have 4 inputs, and it monitors the inputs from a phase monitor, which is a specialist controller that connects between the input unit and the distribution board. It's so we can help isolate the 230 volts from the extra low voltage. By monitoring the state of these inputs on the input unit, we're able to write complex cause and effects to illuminate individual, a selection, or even all of the luminaires on the system. For a good example, if we had a time clock, we could wire that in so that at night time the luminaires illuminate to provide night lighting for staff, thus saving on energy used by traditional lighting in a building. So I mentioned the phase monitor before. So this is the phase monitor, and this is used to separate the 230 volts from the local lighting circuit. It's used to monitor and separate the 230 volts from the lighting circuits from the 40 volts DC used on the FIREscape system. The phase monitor is what we call an undervoltage device. So when the voltage drops below 75% of the nominal, which is approximately 173 volts AC, the phase monitor will activate, triggering the input on the ELIO input unit. The EL2 is the main hub for the system. So this is the only real point that we connect 230 volt supply into it, and this is what powers the whole of the system. It also houses the 12 volt battery to keep the system operating in a full power cut. From the panel, we're able to wire 2 lighting lines. Each of these lighting lines are able to support up to 127 points, and these points can be a mix of standard luminaires, exit signs, high-powered luminaires, and the input-output units. The ELPSU is a device that is used to help bring in a limited number of 12 volt or 24 volt DC fittings onto the FIREscape system. So maybe an existing site had a small central battery unit and you didn't want to change those, or the site wasn't ready to change those. You could fit this unit and it would power those, and then we would control that using one of the ELIO units, thus allowing you to stage change a system. So we'll just, after running through all those, what we'll do now is we'll just have a look at some of the sites that we have actually already fitted these systems, and I'll run through those. So case study 1 is the Sligo Regional Hospital in the Republic of Ireland. That turned out to be a 7-storey, 400 patient bed hospital. Now, it was installed with minimum disruption, complete with the graphics package for 24/7 monitoring. what they found is it has really reduced their energy costs, and that is actually a 34 panel network with 3,800 lighting devices on it. Another example is Teesside University in Middlesbrough. Now that's home to 18,000 students, and the project again has reduced energy consumption across the estate. On the buildings, there are 517 luminaires, 102 exit signs, and there's 8 panels installed across 6 buildings. And that was delivered in phases, again, to minimize disruption. And on our website, there'll be a link at the end of the presentation. There is a video case study on that one. The Kenneth More Theatre in London. Now, that was opened in 1974 and has 358 seats. It was an old system that was urgently needed replacement. And the installation was carried out while the building was still in use. The existing containment and wiring architecture was reused, and that's the beauty of the FIREscape system. There are sites where you can reuse existing cabling. I mentioned that it's a 2-core screened Belden cable, but that could easily be a fireproof cable or a something like an MICC cable. As long as that is tested and proved to be okay, typically you could reuse that cabling. And that FIREscape system was configured with 3 modes. So we had emergency mode, a maintained mode, and a show mode as well. So there's different ways you can program these systems. Porcelanas del Costa Verde, obviously that was in Portugal, and it's a large-scale porcelain manufacturing facility, and the objective there was to reduce, maintain costs and decrease energy consumption. There was about 10,000 euros worth of the equipment installed, both on fire and emergency lighting. And then due to the ease of the installation, the project was completed quite a way ahead of schedule. So we'll just have a little run through of the summary of the actual system. So it is self-testing, and when I say self-testing, it will carry out a 3-hour lighting test on every single fitting every single week in a rotation method, so that not all the fittings are on test all the time. And the way it does that is that it doesn't also light the LED for a full 3 hours. It lights the LED to test it, and then it does an internal discharge test on no more than 6 fittings at one time, and not 6 fittings next to each other. It's a feature-rich system, so it allows you to program this however you really need it to work. We can use lots of different inputs and outputs to do different lighting scenarios, bringing lights on for night lighting for nursing staff if you wanted to put a time clock in there, bring your external lighting on. We use low voltage cabling, so we are running 40 volts DC. So as I will never say that it's completely safe, but it's relatively safe because we know that a very small current can still cause a lot of problems. It's a diverse product range, so the products are there that you actually need. You know, we have the open area with the high powered, we have the corridor luminaires, and they're going to provide you what you need for that site, plus all the accessories that allow you to make it more discreet or weatherproof. It's easy to install and maintain. Going forward, the maintenance is quite straightforward, and the system will tell you if there is a problem. So you're going to know that this system is 100% operational 100% of the time, and if there is an issue, you are able to sort it straight away. And that is something you don't really get with other systems. They're not giving you that information. The last you know is that it worked on your last test. We're able to network the panels together, so we're able to create a larger system, and that is scalable, obviously, to whatever you require it to be. There is integration with BMS systems, so you can start reporting it in different ways and bringing it to different buildings and integrating it with your other systems. It's cost effective. It typically can save you up to 89% over traditional emergency lighting. And that's we get that from a mixture of the energy savings, the testing that it provides itself every week, because it's certified for self-testing, means that you don't have to have a person on site doing that monthly check, wasting time doing something that they may not be qualified to do, they may not be competent to do. So there's a lot of energy cost-effective savings there. Obviously, with it being low energy, it comes straight back to the environmentally friendly side, because we're going to be creating less CO2 emissions as well. And it is a fully compliant system, meeting all the relevant standards that are required. It's also third-party accredited with ICEL for the lighting outputs. And we have things like the LUMDAT files for lighting designs there. And that is the end of the presentation. Thank you very much.
Thank you, Richard. That was excellent. Hopefully we've covered all the main talking points around the system there for everybody. We have got a few wee queries in. If you don't mind, just run us through them, see if we can get some answers for the guys out there. Just a question on the keypad and the use of the keypad for testing and reporting. Does that need to be by a specialist, or can that be done by someone on site, like the end user?
Yeah, I mean, you have a couple of different access levels on the keypad. So for testing, you can actually use the keypad to actually initiate your own tests, although the system is doing that. But then you can have your codes to get in and interrogate it and find the reports. And it can be set up in a number of different ways. There's a number of different user codes can be set in there with different access levels.
Okay, that's grand. You talked there about cause and effect. Can this system be combined with a fire alarm system then?
This system on its own cannot be directly combined with a fire system, but it can be linked to it. So if you wanted to, I mean, the question is, you know, what's an emergency? An emergency light should come on an emergency, but typically it comes on in a power cut. So because we have the input-output units, we can actually introduce an input from the fire system and actually illuminate the emergency lights in, you know, various different ways. But that also leads us on to slightly different systems as well, because there are systems out there that have combined fire and emergency lighting on the same cable. I'm actually proud to say that Hochiki is one of those. We have our FIREscape Plus system, which Atlas are, you know, obviously Pete, you know, you are a registered installer of, and that is combining lighting and fire on the same cable. And that one works in a slightly different ways, that we can actually bring on emergency lighting in the actual fire zone that is activated, right to the point we can actually start playing, well, not playing around, but turning off exit signs and putting red crosses through them to suggest that that is maybe not a safe route out of the building. So there's some really, really clever innovations there.
Okay. Another one there, there's been a few references to the energy savings. Could you just sort of briefly explain the difference between the current consumption of the downlights compared to a comparable mains powered fitting?
Yeah, so a typical 8-watt luminaire is going to pull about 12 watts. Now, it's an 8-watt tube, but what you're doing with an 8-watt luminaire is you're charging the batteries 24/7. Now, what the FIREscape system does is it charges the batteries to a point, and when it realizes the battery is full, it turns off the charging circuit until it's needed again. So that's how, you know, so initially we are more efficient in charging because we're using half a watt, but then it reduces down to 0.1 of a watt because it's just maintaining the unit and will only charge it when it's actually required. And that's how we actually get up to 89% energy savings over traditional emergency lighting.
Okay. With one here, who does the annual test for certification?
You still need your annual test really carried out by a third-party company, such as yourselves, Atlas, I mean, sorry. And you've still got to go in, you've still got to do that annual test. So that doesn't change. But what we're eliminating is the fact that there should really be no major problems with the system, because throughout the year, that system has been maintaining itself, doing tests. It's taken it away from somebody on site who, like I say, is maybe not qualified or competent to do that, or quite often doesn't want to do it or forgets to do it. So it brings it back to, you know, the annual test that is Atlas is going to do in this case. You know, you will still have that test. But again, the system should be fully working, so you shouldn't have any real major issues.
Okay, no major surprises anyway. Another one here might be a bit trickier to answer. How do install costs compare against other systems? I suppose, and it's going to, you know, change from system to system. Obviously, the install costs, I'm imagining, would be slightly more, but because of the vastly reduced running costs, you're going to see a return on that investment a bit sooner.
Yeah, I mean, you are going to see a return on investment in this system via the energy savings and the maintenance side. Look, it is slightly more expensive than traditional systems. And when I'm talking traditional systems, I'm talking your bulkhead that is powered off 230 volts. When you start to compare it against something more like for like out in the market, then yes, it does compare a lot better. You know, we're very, very competitive from that side of things. I'm not going to discuss exact costs and everything, because obviously that will be for yourselves to sort out with your customer, Pete.
Okay, no problem. But yes, we can sort of safely say there's a sort of slight increase compared to a normal one, but
yes,
this has to be seen as a life cycle.
Yeah, I mean, typically, to give you an idea, we've had reports from customers that with the reduction in the maintenance and the energy savings, the system has typically paid for itself in around about 5 to 6 years. Depending on how you set the system up and what else you use it for, we have had reports that it's paid for itself within about 2 years.
Well, there you go. But I suppose then we'll just look at it on a case-by-case basis, really, guys.
It is, unfortunately, yeah. It's very difficult to quantify, unfortunately.
Exactly, no problem. And then one more, we've got what is the anticipated battery life and how readily are the batteries replaced?
Typically, we're held a little bit by the British standards on this with the certain technologies of batteries. So we are still recommending that the batteries are replaced every 4 years, similar to your normal batteries, in your nickel cadmiums in your typical fittings. Now, the batteries are readily available via people like yourselves, but they are actually a lot quicker and easier to change. So the cost on the battery is maybe just a fraction more than your nickel cadmiums. But to give you an idea, I was an engineer and I used to change emergency lighting batteries. Now, I would say on average, I could change batteries in an emergency light, say 15 minutes, something like that. Let's argue 10 minutes if I was really, really quick, but I'd say 15. I say you could change the batteries in this in under 2 minutes. Typically, you'd use your smoke poles. You'd unclick them, bring them down. It's on a plug, and the battery will literally pop out. The battery comes out, and you literally click a new one in, and then you just put them back on the poles and click them in. So you're going to be saving on your health and safety side of things, making it a lot simpler and a lot easier. It's a lot quicker to do. So, you know, when you actually work it out, it works out more cost efficient for changing batteries than traditional batteries.
Okay. And can that be changed by anybody, or is it preferable to have it done by the maintainer?
No, it could be done by the site maintenance on, you know, it's relatively safe to do. Well, it is safe to do. It's quite simple. And, you know, all I would suggest is if the site wanted to do it themselves, would be just for someone like yourselves, Pete, to run through what they needed to do, show them how to do it. And then, yeah, absolutely, they could do that themselves.
Okay. With reference to the distance between the fittings, has this meant a decrease in the number of fittings in comparison to existing systems?
That is obviously going to depend on the site. Now, yes, basically, if you were planning it as an open area, not a lot of doors between corridors and things like that, then yes, you're going to use less fittings. Obviously, it's all dependent on the light output of the fitting and if that other company has got the certified lighting data. But typically I have found that I recently did a scheme for somebody else. I worked with them on it, and over a couple of hundred fittings, I think we managed to take out 30 fittings, and we were easily still a lot higher than what we actually required on the floor.
Very good. Is there a maximum cable distance on the 127 lighting line?
Yeah, so we have a calculator. This is obviously done at design stage. So with the calculator, you put in what fittings you're putting onto a circuit, because certain fittings pull more power. Now, 127 points per line is the absolute maximum. You'd never really fill it that full. Like you would with a fire alarm system, you're going to leave a certain percentage spare. I would typically say keep it around 80 to 90 fittings, then you've got a percentage spare, but it also means that you can extend in the future. If you were running, say, 80 fittings and there were standard fittings, you're going to approximately get between about 800 and 1,000 meters using something like a 2-core 1.5 screened Belden.
Okay, thank you for that. And then last up then, we've a question, and don't know how easy this answers. What sort of life cycle would you expect to achieve off the system? I suppose that depends on usage and everything that goes with it.
Look, we've had this system available in the UK for over 10 years now. And we don't get many returns of faulty products or anything like that. We would expect the system to last more than 10 years. The typical lifespan of the LED. Now, if we were running the LED in full power all the time, which you wouldn't, that LED will last 10 years. It's got a 10-year lifespan on the LED. Typically, you are going to be having those emergency lights as a non-maintained fitting, and they're going to be coming on. I'd say if they come on more than about 10 hours in a year, I'd be surprised. So as far as the LED, I would expect them to last quite a long time. Everything else, well, Hochiki pride themselves on building quality, solid products that, don't fail. To give you an idea, as an engineer, I remember taking out 27-year-old detectors that still worked. So I'd love to say, yes, you have to change it at 10 years, and that's speaking from a sales point of view. But no, it's solid quality equipment that does really last.
Excellent. Okay, I think that is us for the Q&As that have come in. We've got a hand up from Philip Ham. I think, Graham, I'll ask you to unmute Philip so he can ask his question.
Okay.
You with us, Graham?
Yes, I'm here. I'm just trying to...
If you go into the attendees there, I think you should have the ability to unmute Philip.
Yep. Don't seem to be able to unmute him.
Sorry, Philip, I think technology's best in us. Are you able to type in your question into the wee Q&A section at the bottom there? If you just hover your mouse over the bottom of the screen, it should offer you the Q&A. We have a quick one in there, Richard, just while we're trying to sort that. Can other lighting be fitted with the Hochiki equipment? For example, if the client wanted an external light fitting to be a combined fitting?
Unfortunately, at the moment, no. It is our own protocol, so it is bespoke to our own system. You could control a separate emergency light. If you wanted to bring another emergency light on via the inputs and output units, you could do it that way, but unfortunately not as a combined. I also noticed the one above it, what country is it built in? So the equipment, the majority of the luminaires are actually built in Gillingham in the UK. The control panels come from our partners in Finland.
Okay. Well, I think that is us then in terms of the questions and the queries. I think that's pretty much us. I'll get Graham to pop the wee feedback poll up onto the screen if you don't mind. Yeah. Guys, if you don't mind, just have a quick click on that and I will tell you about our webinar that we're going to have next week. Next Wednesday, we're going to be joined by our friends from AidCall, the Grand AidCall, and that is a wireless nurse call touchscreen system that we've been putting in across a lot of the trusts and the care homes and medical centres and things like that. So we're going to have those guys come and join us next Wednesday at 2 o'clock. There'll be a wee link sent out as normal. If you guys want to come in and join us for that, please do so. Otherwise, I think I'll just wrap this up. Thanks again to Richard. If anyone I think has any specific queries, I'm sure we're going to be able to accommodate a video call with themselves and Richard and have a good sort of specific discussion around your needs if you do want. If you want to just get in touch with any of us here at Atlasworld and we can set that up for you. We're also going to be making a recording of this webinar available on our website for anyone to view and to pass on to those who couldn't make it today. So hopefully we'll get a link sent out for that in the next couple of days. Otherwise, thanks to all who joined us today. It's much appreciated and hopefully we'll see you all for next week's webinar. Okay, thank you. Take care. Stay safe. Good luck.
Thank you.